Hi, Shekhar. Good morning.
Hi, bro. Good morning.
Yeah, yesterday when we discussed, like when we are while we are writing the EIP, right? So under the VPC, initially we thought that we have to put the custom VPC default resource dot custom resource dot attribute. Correct?
Yes, bro. We tried with the default VPC also.
Correct. No, that's a mistake from my end actually.
Okay.
Whenever in the EIP, every time we have to give VPC is equal to true. It doesn't mean it's a default or a custom VPC. The meaning of VPC is equal to true. It means it will grant the public IP address in the EIP. That's it. It will not attach to any default or custom VPC. Okay, but that is the syntax they are Terraform is following it. Nothing else in terms of whether the VPC is equal to true. It means true means the default. If you put anything, it's not the custom. It's not nothing like that.
Okay.
Got the point, right?
Yes, bro. But we tried with VPC is equal true also, right?
Yeah, when we tried VPC is equal to it worked.
Yeah, it worked, but we thought it is for default VPC.
Correct. Yeah, it's my mistake that I thought it's a default VPC. When I checked the documentation after the class, I got to know that VPC is equal to true. It means it's not for the default. It's a standard syntax for the EIP. It doesn't care about whether the EIP which is creating the new public new IP that we can assign to any of the things actually. It doesn't care whether that we can assign that to a default VPC or custom VPC or whatever it may be. Okay, that's the syntax as per the documentation.
Okay, bro. Yeah.
Hope you're able to see my screen, right?
Yeah, bro. Yeah.
Yeah. Today is the most important class, man. First, what we will do is today, what are the services that we have written yesterday? Hope you remember the 7-8 services that
Yes,
we will
bro.
write in the modular format. Before
Okay.
starting the modular format, I want to showcase how the modular format looks for one service. Then we will implement that for the rest of the services. Okay. The first
Okay.
and foremost thing, what do you mean by modular? Any idea, Shekhar?
Module. A couple of services tied together. I mean, it's like
No, nothing like that. Nothing like
okay.
No.
Okay.
Okay. So in general, like yesterday, when we are writing the main file concept, we have written 7 or 8 services all at a time in one file, correct?
Yes.
In the module, what happens is every service that we will break and will maintain a separate file.
Okay.
The reason for that one is reusable concept. Reusable purpose, we will maintain a module.
So number of .tf files.
Exactly. So it means that anywhere, if you heard a terminology called as modules, the first thing that should comes into your mind is it is a reusable. You can use it as many as times you want. You can fetch it as many times you want. Got it?
Yes.
So let's take an example. I'm just creating D9. Okay. So what I'm about to do is, see, listen carefully over here. I'm inside the day9 folder. I'm creating new 2 folders. I'm naming first folder as calling function, second folder as modules. Okay.
Okay.
So now I'm going inside the modules and I'm creating another folder called as, now let's say we will write for EC2 instance. I'm creating as EC2 folder. Okay. See, now I'm into the EC2. Okay, let's go for tree.
Wait a second. We have created day9 and then 2 directories, and
Don't
then
worry,
inside
no
modules.
worries. Yeah, no worries. Okay. I'll use a tree. You'll get to understand what we are doing.
Okay.
Check now where we are now. See, we are inside the day9. Here I have created 2 folders. One is calling function, another one is modules. Okay.
Yes.
Inside the modules, I created another folder called as EC2.
Yes.
Okay. Now here, are you clear up to here?
Yeah, bro.
So now I'm going to the inside modules and EC2. So I'm checking PWD. I'm in the EC2 folder. Okay.
Okay.
Here I'm writing main.tf. Okay.
Inside EC2.
Exactly. Okay.
Okay.
So what I'm doing is now we should not declare the provider over here.
In mod. Okay. Only the resource service or resource.
Exactly. Sorry. What I've done. I am commenting it. Yeah. Instance underscore type. You'll see the magic now. Var dot instance underscore type. AMI is equal to var dot AMI. Tags is equal to name is equal to var dot EC2 instance spelling, come on. Instance underscore. Let's put a capital just for a good understanding. Okay. Save it. Just putting a 24. Again, I missed a bracket. Let's go to the EM again. So here you're clear, right? You're aware of all these things and etc. Correct?
Yes, bro.
Now I'll be creating variables.tf. Okay. Now what are the variable? And I hope you're aware. The 3 or 4 things will be mentioned here.
Instance type and AMI we have defined.
AMI.
Then EC2 name, EC2 instance name. Underscore name.
Done,
Yes.
right?
Yes, bro.
Okay. See, now I'm going back.
Okay.
So I'm hitting tree again. So what we have, I'm under the day 9 folder. Okay. Day 9. What we have now, we created 2 folders. One is calling function. Another one is a modules. Inside the modules, we created a EC2 folder. In EC2 folder, we have what? Main.tf and what? Variables.tf. Correct?
Yes.
Now I'm going to the calling function. Okay.
Okay.
Ls, nothing is there. Now here I am creating ec2.tf.
Okay.
So here the funda starts. Put module, put any name which you like here. Okay. It's like a defined resource.
Okay.
Next, source. As of now, I'll leave empty. Next, here, what are the variables that we have assigned in the under the modules? Those we have to put it here. Got the point?
Module EC2, whatever we can give, and then what is that source, bro?
1 second. Let me open the another bash terminal so that it'll be understandable.
Okay.
Oh. 1 second. Shut. Yeah. Okay. See, I'm going into the variables. Whatever the variables we have assigned here, put the same over here.
In source.
No, under the source. Source, I'll say you what to
put in
the source.
Okay.
You're getting the point?
Yes, yes, yes.
See here. We have put instance underscore type, and we have put AMI and EC2 instance underscore. So they should be same. Okay.
Yes, yes.
And now see here, again assign another variable to this one. You can put the same name over here, no problem.
Okay.
It might be some tricky at the first moment, but when you write it, it will be some easy. But writing part will be more.
In real time, which one will go for that one main.tf, terraform.tf wheres, or this kind of modules we will prefer?
Modules only, modules only will be writing in real time.
Okay, because we need to reuse them.
Exactly, exactly. Any doubts until here? Leave up the source now. I'll answer you. Any doubts until here?
No, as of now, no.
Okay, now coming to the source. So what we have to give in the source? Here we have to mention the path where exactly our EC2 folder is. Got the point?
Okay. Where our variable file is?
See, in PWD, here is our EC2 folder, correct?
Yes.
If you hit ls, we have main.tf and variables.tf. This is the EC2 content, correct?
Yes.
And under we have created EC2 folder, correct?
Yes.
So now we have to give this path, copy, put it here.
Okay, this source path we can take it as wherever the variable file lies, that path.
Exactly. Not the variables, the EC2 folder.
So why EC2 particular? Because in module we mentioned EC2, that's why EC2 path.
Wait. This script is totally for EC2 only, right?
Okay.
Then we have to give the path for EC2. If we write a new script for the, let's say, EBS volume,
okay,
give the path for EBS.
Okay, okay. So what for whatever service this script related, that service path.
Exactly, exactly. You got the point, right?
Yes, yes.
Save it. Now we have assigned this thing, variables.tf. Now here, which variable we have to put it?
Whatever we have kept earlier.
Whatever the variable you have assigned in here. In this EC2.tf, whatever the variable you have assigned here, those things we have to put it under variables.tf.
Again, we need to define same variables.
Your wish. If you want to put the same names, you can put it. If you want to put the different names, you can put it.
Okay.
But the same name here, the variable name and the EC2.tf variable name should be the same.
Okay, okay.
Getting it right? It
yes, yes.
Initially, it will be tricky, but still.
And then EC2 underscore instance and these three variables we have defined there as well.
EC2 instance underscore
name.
So now we have defined everything and we have to define a provider as well, right? See, now I'm going to the provider. I'm creating a new file called vim providers.tf. Got the point? Here,
okay.
Use a provider, AWS. Got it?
Yes, bro.
See now.
Give ls, bro, once.
Yeah.
Okay.
So now what I'm doing is I'm hitting tree now. So now observe carefully. Okay, wait. Let me go to back and hit tree. Yeah, now observe carefully what we have. Let me clear the screen. Yeah. Now observe carefully what we have.
Okay, for EC2 service, we have main.tf and variables. And this EC2 main script we have defined in calling function.
Exactly. You got the point?
Yes.
Any doubt so far?
No. Now, for suppose in place of EC2, if we have another service like EBS, so in calling function, we will be writing EBS.tf.
Correct. And those variables, we have to put it in variables.tf.
TF and provider is default. Okay.
Yeah, up until here, it is clear?
Yeah. Yeah, bro.
Yeah, just go to the calling function. We have to write.
And whatever the directory names we have created, calling function and modules is the same syntax we need to follow.
Name, you mean the names of the calling function and modules?
Yes.
Your wish, you can put Shaker and Raj.
Okay.
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 See, now we have to assign the Terraform.tf vars in the calling function.
Yes. Yes. Okay.
What is the AMI? Put it aside.
Instance,
Instance underscore type. EC2 instance underscore type is equal to
EC2 underscore name is equal to.
sorry, correct. EC2 instance underscore name. Yeah, correct. Let's put Raj this time. I'm copying the AMI from the console. Okay, I'm saving it. So I'm just going back and again hitting tree. See, check now.
Yes, bro.
So clear, right?
Yeah, whatever the service we have, whatever the service configuration we have in modules for that service, we have created in calling function.
Exactly. Any doubts?
No, but that's it, right?
Yeah, now we will execute it. Yeah.
Okay.
Where we have to execute now?
Go
to the yeah.
Modules?
No. See,
Okay.
if you go to the modules, we do not have anything called as providers. And where we have mentioned the providers?
In calling function.
Exactly. Only one, what do you call the straight mark you have to comes in the mind is wherever the provider file exists, we have to execute there. So we have a provider dot here, correct? So execute here now. See, it picked up from here. What is this? Validate. Perfect. Next, plan. See, one is adding it. Okay, before executing it, I want to show something. So now where we are in PWD, correct?
Calling function, yeah.
Hit ls. Okay, this one. Hit ls-al. Whatever you have now, whenever you are hitting Terraform init, the path in the calling function under the ec2.tf, we have put a path, correct? This path.
Yes, in source we have defined it.
Yes. Those things will be downloaded here. If you hit ls-al, you can see a directory called, this is a hidden directory called as .terraform. If you go to inside the .terraform, ls, see, modules, ls, see, EC2 is here.
But we haven't given this providers, no? From where it fetch.
See,
providers?
That's the funda. See, that's what it is saying is, wherever we give, like when we are hitting Terraform init, in the source under the calling function, we have given the path, correct?
Yes.
It goes to the path and it will read and it will download whatever there inside the path under the .terraform.
Okay.
See, now what happens is, see, I'm just going completely outside. I'm just going to the day 9. I'm just going to the calling function. See, I'm clearing the screen. If I hit the Terraform init now, See what it is. Just read the messages over here.
Initializing modules, initializing the backend, initializing provider plugins.
Okay. Did he showcase anything saying that it is downloading or something like that?
No, nothing.
Because the .terraform already exists. That's the reason it is not showing. It is not downloading. Whenever anything that is been removed over here, if you hit the same command now, see it is downloading again.
Initializing modules. Okay. Initializing. Okay. Along with this path downloads, it will download provider.
Exactly, of course, because we have providers over here, right? It
Yes.
automatically does everything from here.
But
That
in
is the
source,
funda.
source we have not given this provider path, right?
No. Listen carefully.
Okay.
In LS, we have directly given a file called provider.tf.
Yes.
It will read from here automatically. Previously, we used to give this provider content inside a file, correct? In same file, we have given it. Now we are breaking all those things into pieces.
Okay.
Got the point?
Yes, bro. Yes.
See, now as usually, I'm applying it. So any doubts so far, Shaker? So this is a concept of modules. When we write, now we will start writing all the services which you have written yesterday using main file concept. Now we will write all services using the modular format.
Okay. But
So
compared to that, this one is scripting or whatever the files is a bit lengthy. Because two-time we are maintaining variable files.
Yeah. The reason for that one is, as I said, you see, it's created over here. See, Raj, it's created. Okay.
Yes,
so
bro.
The concept, you might be thinking, yes, it's a too lengthy, but in the real time, like, we will be using only the module concept. The reason is you'll get to know how we can use a reusable concept tomorrow. End of the day, you'll be understanding the importance of modules.
Okay.
Now you might be thinking, this is very lengthy. We are assigning variables twice times. And it's, yes, I do understand that you might be thinking in this way, but you'll get to know the beauty of modules tomorrow, end of the day.
Okay.
You'll get to know it.
Okay.
So now you got it, right?
Yes, bro. As of now, it's cleared.
Okay. Now let's start creating every services how we have created yesterday, but now with the help of modular concept. First, what we have to do is, like, let's destroy this one. Let's under progress for destroying it. It's taking less than a moment. Yeah, it's destroyed.
In real time also, we will maintain 2 directories and execute like this, or we will maintain number of directories.
Exactly. Yes.
So wherever the provider lies, from there we will execute.
Exactly. Okay. And now I'm going to modules.
Okay.
Now we'll start creating one service. Okay. Now what I'll be doing is, let's go back. Let's go to the yesterday's class, day 8. Just go to the main.tf and just put it aside over here. Okay. I'm putting aside in my another window. Okay. So now what I'll be doing is, now we'll create a directory with a name called VPC. Okay. Now I'm going inside the VPC and I'm creating the main.tf. Hope you are getting it.
Yes, bro. Yes. Individual services TF files we are creating.
Exactly. See the resource name, and we have assigned the var block. Okay. Come back now and go to the variables dot
This
tf.
this too is mandate.
Of course, for everything. Variables, VARI. Okay. And hope you are aware that we have to give 3 or 4 things here. Now, VPC underscore CIDR block. Okay. I'm saving here. So now VPC part is done. Correct. I'm hitting
Yes,
LS. Now you have EC2 VPC. Now let's go and create subnets. Okay.
Okay.
Now LS, just go to the subnets, create a new main.tf. I'm copying the subnets funda. You'll be able to understand why I started yesterday the main file concept with all the services. Okay,
Okay, bro.
this, hope you're aware what is this and everything. I'm not going in that. Variables.tf, open. Let me do one thing. 1 second. I'm making easy to copy and paste. Yeah. What are the variables that we have used over here?
Public subnet.
Correct.
Or yes.
Save. LS, going back. Now how many we have completed? Now just go to the next. What we will create? We'll create
Table. Route table.
Okay.
You thought of creating EAP, bro?
Anything, man. Anything we
Okay.
can. It's no order, nothing. Okay. Just go here. Main.tf. Enter. I'll be changing few things. Okay.
Okay.
I'll showcase now what are things I'll be changing now after creating of this thing. Paste. Creation of route table and association. Okay.
Yes, bro.
I'm just saving as of now.
Okay.
Just go back. Just go back. LS. Just go to the subnets. LS. Just go to the main.tf. See here, we have done something. What is this?
A VPC, bro. We're attaching that VPC.
Correct. But here, we do not have a VPC block, right? How
yes,
it will
but this,
how
this
it
is
will
this is an individual service.
Correct.
Source.
I'll say you. In those cases, what we have to do is first assign a variable. I'll say you how to make that. First, assign a variable which doesn't have a communication. I'm putting the variable name as var underscore VPC ID. Okay, you'll get to know.
That may be beyond my abilities at the
moment. My Google is reading. Okay. First, assign a variable. You'll get to know in few minutes. So now you might be having a question. For what are the things that we have to assign a variables? It means, see, now we are in a subnet block. Previously, we were writing the AWS underscore VPC dot ID.
Yes.
If we have a VPC block over here, then we have to write that. But we do not have a VPC block, right? That's the reason we have to assign a variable for this one. It's clear?
Yes, bro.
Okay, it's clear, right?
Yeah, bro. But in this subnets only we have variables, right? Here we need to give that VPC ID.
Correct. See, now we have created a new thing, right? Now I'm adding a variable as
well. Okay.
Okay.
Yes.
Okay. Now go back to the route table. So, okay. First, I'll be adding the variables .tf. How many variables we have in route table? Public route table, private route table. Only 2 things. Correct. I'm saving it. Just go back to the main in the same route table. Okay. So here, what are the things? The communication is not there again.
VPC is not there.
Okay, VPC is not there. Give the same name what we have given over there.
Okay.
Where dot.
VPC underscore ID.
Okay, you can give any other name also, but for making a good understanding. Next, what else we have?
Siemens earlier block we don't have here.
Where? Line number?
Route table. Okay.
Which line number you're talking about?
6th.
Okay.
No.
Anyway, we have this thing is right. I mean,
We'll define this variable.
We have already defined the variable. Next.
Gateway, bro.
Gateway.
Right.
What we have to do now here?
Create a variable. Assign a variable.
Yes, because we do not have an internet gateway, correct?
Yes.
So I'm putting it as var dot ig. Okay, just for understanding purpose. Okay.
Okay.
That's it. var dot ig. It's enough. Okay. Next.
And down to that again VPC we need to edit. VPC ID. Yeah.
Var dot VPC underscore id. Next.
This gateway ID.
Correct. Var dot ig. I'll put as id ig and sorry. This is a gateway for NAT gateway, right?
NAT gateway. NAG you can take.
I'll put NAT underscore id. Here I'll put as, just for our understanding purpose, I'll put as ig underscore id. Internet gateway. Okay.
Okay.
Just for our understanding, we can put whatever. Next, anything is there?
Yes, bro. We don't have this public and private subnets also in this script.
Yes. Then what we have to do now?
Need to give a variable. We need to define as variable.
Exactly in the line number 23. Here, what we have given previously, public subnet, right?
Yes.
Now what we have to give? Var dot public underscore subnet. Okay.
Okay.
Next, what we have to give? Do we need to change line number 24?
24 route table ID. No, bro.
Why?
No. We
Why
have
we
this route. We have this route table configuration on top.
Correct.
Perfect. The same bluff in the same
perfect.
file.
Perfect. Yeah, that's the thing I want from you. Here also we have to change it, right?
Yes, bro.
So how many new variables that we have got it? This is
1, 2.
This is same.
3, 4,
5. Save it. Start writing for that one.
Variable VPC we have defined.
VPC underscore ID.
And then internet gateway and NAT gateway.
Right. What we have named it? IG
underscore ID.
Next, NAT underscore ID, correct?
Yes, bro. I think NATG we have given or NAT?
NAT only. Yes.
Okay.
Next, what we have to give? Public
subnet ID.
Subnet.
That's it. Private subnet.
So we should not confuse ourselves later on actually. See, if we have written here, let's go back to the main. We should not confuse ourselves. We'll do one thing. In this public subnet, we might confuse, right? I'll put it as like this.
Okay, bro.
The reason is we have public subnet variables also, right? It might confuse it. I'm putting public underscore subnet underscore route so that we'll understand that this variable belongs to the route table.
Yes.
Correct.
Yes.
So in this way, you have to organize the variables yourself. Underscore route. Underscore route. Saving it. So that's it, right?
Yes, bro.
Now just going back to these things. Now next I'll be creating the internet gateway. I'm naming it as IG. Just going to the inside the IG and creating main.tf. IG, where are you? Where are you? Here it is. Copy. Okay, and anything that needs to change?
Yes, bro. VPC.
var.vpc underscore id. Correct?
That's it, bro.
Next, we have to create the variables.
Variables.
.tf. Correct?
Yes, bro.
Here, what we will be adding it. We'll be adding as of now with this thing. Variable vpc underscore id. So I'm
ID.
just copying all these variables from yesterday's class only.
Yes, bro. Yes.
I'm saving it. Come back again, and what we have left over? We have created route table, internet gateway. Yes, we have left over with EIPs, NAT gateways, and etc. Right?
Yes, bro.
I'm creating a NAT. Going inside the NAT.
Main.tf.
Okay, now what I'll be doing is I'll be putting these two things in one place. It's just a piece of cake, right? Here,
Okay.
do I need to change anything?
Yes, bro. This subnet we need to change.
Public underscore subnet, right? Yeah,
Yes.
exactly. So what we will name it here, the AWS underscore subscribe. Okay. What we'll name this belongs to subnet underscore ID. Var dot public underscore subnet, and it is belongs to what? NAT part.
Yes,
You got
bro.
it right? How I have segregated it?
Yes, bro. That's it.
Yeah. Now just go to the variables.tf ls, and we have written for NAT. Okay. Paste.
And we have defined the variable public subnet.
Public underscore subnet,
Subnet underscore
NAT. It
yes.
belongs to the NAT. That's the reason I've used a NAT. Is there anything else that we missed it in the NAT? EIP is there, public. Yeah, that's it. Okay, and just go back. I'm going back. LS, and did we miss anything else? Anything we miss it? That's it, and we are creating EC2. Oh, we already have an EC2 right here. Yes or no?
Yes, bro.
Yeah, I'm just going to the same EC2 folder. Okay, I'm just adding few this line over here, and rest of things is same, right? Copy. So what we have to put it here?
Var dot.
Correct.
Why this line, bro?
What we are doing now? In the custom VPC, we are creating EC2 instance.
Okay, but
You forgot?
no, bro. But we have okay, but no VPC entry we gave. We directly gave subnet entry.
You forgot yesterday. In the EC2 instance, if you want to, this EC2 is a custom VPC, the custom EC2, correct?
Yes.
This custom EC2 needs to deploy in the custom VPC.
For that, we need
have to
only
give-
subnet. Okay.
That's it. That's it.
Okay. This is from
I'm naming-
documentation. Yeah.
Exactly. I'm naming this as EC2. Okay, just for our understanding. So what is a variable that we have to use? The extra one.
Subnet.
What I have put it? Public underscore subnet underscore EC2. Okay.
Yes, bro.
So now we are done with the modules part, correct?
Yes, bro.
I'm just coming back. I am hitting tree button for your understanding. Let's clear the screen. Just check the tree button, how it is looking like.
Yeah, bro. In modules for each service, the main configuration along with variable we have defined.
Exactly. So we have done with EC2, internet gateway, NAT gateway, route table, subnets, VPC. In the NAT we have EIP as well.
Yes, bro.
Correct. Now
Yes.
just go to the calling function ls. Okay. Okay. Just for understanding, I'm removing the Terraform state file as of now because nothing is there here.
Okay.
Just for putting in a neat way. Okay. Now hit check here. Nothing is there here. Now we have created ec2.tf, correct?
Bro,
So
that
similarly,
hidden directory dot terraform might be there.
yeah, it will be there. We will be delete. Nothing will happen if you are not delete also. It will download the new things. That's it. Let's delete it. If you want, you can delete it. No problem. Okay. So what we have now, just go to the calling function. Okay. So now we have created ec2.tf, correct?
Yes, bro.
Now I'm just going back to the are these things in a separate one. What is this? See, what I'm about to do is see. Go to our today's session day 9. We have created all the things, right? In the modules.
Yes, bro.
Just go to the variable section of each and everything. So now we have already done with EC2. Let's go to the IG. Oh, yes, we have to add one variable in EC2. Now just go to the IG. Okay, let's go to the variables. And what we have here. Okay, I'm just putting in another screen. Now what we have to do, vim.ig.tf. Shut up. Vim space ig.tf. Hope you're understanding module. Name it whatever you want. I'm naming it as IG. Source is equal to. So you remembered now where exactly it is there.
/root /day9 /ig.
Now it's under the modules.
Yeah.
Then it is under IG. That now what are the variables we have?
Same variables we can define.
Exactly. Put the same name over here. If you want to put another name also, no worries. You can put it as the other name. You can put any name which you wish.
If
Okay.
we put other name means while we executing which one that
See,
it will take.
this is the variable which we got it from modules, correct?
Yes.
For this variable, we are giving another variable for this one, correct?
Yes.
No, it will consider this one because this name only will be giving in the terraform.tf files, correct?
Oh, yes.
Automatically it will read. You're getting the point, right?
Yes, bro.
So now here what is there? VPC underscore ID, I'm putting equal to. Okay, here one funda is there. I saved it, I have not given anything. Okay. Okay, what are the most important thing I want to showcase this? Okay, let's write everything. Okay, wait, I don't want to confuse you now. Okay, let's write as of now where only.
Where that VPC underscore ID.
1 second, it is not exiting. Okay. Let's write var.vpc as of now. Right. Okay. I'm saving it. Now, what is the next thing that we have to create it?
Where
Anything, man. When vpc.tf. Let's go. I'm going to the VPC folder. I'm just copying it.
module EC2 source and then the variables. So
Module VPC. Source is equal to, hope you are aware, root day 9 modules VPC.
Yes, bro.
So what are the variables we have here? VPC underscore CIDR block. Only one variable we have. That's it. Var dot VPC underscore CIDR block. That's it. Saving it. Next, subnets.tf. Hope you are getting it right.
Yes, yes, bro.
Subnet, I'm using, okay, subnets.
All those modules with names and source we are defining in calling function.
Exactly, man. D9 slash, and what is this? Modules slash, what we are writing now? Subnets. Let's go back to the subnets. Public subnet is equal to
Public subnet.
next
Private subnet. Bro, with modules concept, our course is completed. Huh?
exactly the last component with the Terraform registry in practical.
Okay.
Right underscore subnet, and what is this? Underscore subnet underscore name.
Bro, in real time, how often you will be working on Terraform and provisioning this infrastructure? Bro?
Man, it's at a one-time task for in Terraform, right? Whenever you get a requirement, you'll be writing over there.
Okay. That time we can make use of all these things, right?
You'll be able to understand at the time how a reusable model will come, reusable models comes into the picture, and how you can use this registry. You'll get to know. That's what I said. Like tomorrow, end of the day, you'll be understanding the importance of modules. See, okay, here it is fine, right? Public
Yes, bro.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah. Okay, and the next thing, what we have to write?
NAT gateway.
Yeah, we will be writing the, what do you call it? Route table. Route table.tf. Let's go into the route table here. Okay, module. Source is equal to root. Hope you're aware. Modules. Route table, correct?
Yes, bro.
Next, what are the things that we have to put it here?
Public route table, private route table.
Next,
Private route table. VPC. Public subnet and private subnet.
yeah, ideas.
NAT underscore ID. So you are certified in Azure as well.
Hmm?
You are certified in Azure.
Yeah, I'm certified in Azure. I'm certified in Terraform.
Azure, which one, bro? AZ
Is in
104 or
I heard I was certified Azure one year back when I don't remember AZ900, I think.
okay.
I don't remember the certificate name.
Okay.
Okay. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Correct. I'm
Yes,
saving
bro.
it. Okay. Next, what we have left over with? EC2, IG, Internet gateway, routable, subnet,
NAT gateway, bro.
NAT.
NAT. With NAT, we covered all. Module, NAT, source, variable, NAT gateway, and
Yeah, NAT only
VPC.
the last part. Yeah, exactly. So this. Module. Root, and what is this? Day 9 modules NAT. So what variables that we have used? Only 2 variables.
NAT gateway.
Sorry. One second here. Sorry. Name. What do we have over here now? Public underscore subnet underscore NAT. That's it.
Yes, bro.
And we have to add one thing on in EC2.tf as well, correct?
Yes, the subnet we need to add.
What's the name I put it?
Subnet ID.
Let's check. Nothing like. Okay. So here now another important thing comes into the picture here. Okay. Let's go to the VPC now. The thing is here. What's the next thing will be comes into the mind is subnet. See, you remembered what you remembered. Just go back here. Okay. You remembered one thing, right, Shekhar? Hello?
Yes, bro. Yes.
Yeah. We have assigned a variable, correct? We have assigned a variable. What is this? Oh, this is variable.tf. Okay, we have assigned a variable. Let's say what I'm about to showcase is, let's go to the subnets. In Vim, here we have assigned a variable because initially it should be having us aws.underscore vpc.vpc.id, correct?
Yes,
I
bro.
mean to say defined resource dot custom resource dot attribute.
Yes.
We do not have a VPC block over here. That's the reason we have assigned a variable over here, correct?
Yes.
So now we have to establish a connection from subnet module, subnet block, okay, subnet folder, or else in a layman language, subnet folder to the VPC folder, correct?
Yes, bro.
Yes or no?
Yes, bro. Even though all these are individual services, but while executing, it has to connect.
Exactly. This needs to connect it, correct?
Yes, yes.
So now the funda comes here is most important here. 1 second. Just put it in a block. I mean to say the big letters. 1 second here. I'm getting more cough. Something happened to me. Okay, fine. Drink water. It's enough for me. Okay. So here, okay, let's go to the what do you call our concept. Day 9.
Bro, screen got some. Yeah. Okay.
Okay. So here we are going into the modules. Okay, we are going into the subnets. Correct.
Yes, bro.
So what we discussed is we want this should establish a connection between here and there. Correct.
Yes.
So now what is this? This is belongs to the VPC. Correct.
Yes, bro.
So what we have to do now is we have to create an output variable of this VPC actually. How we will do it now, you can see on the screen. Just go to the VPC folder. Okay.
Okay.
Just go. Okay. I'm hitting cat main.tf. Okay. And
Okay.
here I'm creating a new file called outputs.tf. Okay.
Okay.
Here, what I'm writing is be careful. Output, any name you can put it here, any name you wish. Just for
Okay.
time being, I'm putting as VPC. Okay. Here, value. This is a syntax for writing it. So I'm saving it. Okay. Just for I have not mentioned completely. So what we have to mention here. So what we have to do is AWS_VPC.VPC.ID. Whatever we mentioned over there, we have to put it here. You got the point?
Yes, bro.
Come here, AWS_VPC.VPC.ID. You got the point?
Okay, this line is from VPC configuration.
Exactly. This line is for the VPC configuration.
Okay.
Any
Have you
doubts so far? Yeah.
No, bro. Have you closed the bracket in outputs?
Yes, I closed it.
Oh, okay, okay, okay.
So now, here some tricky will be there, man. You have to understand. I'm going back to the calling function of our subnets.
Okay.
Okay. So
Okay.
now here, what I'm doing is I'm removing this one. I'm using a new thing called module.vpc.vpc. Can you say me how we got this one? Any idea?
In module VPC, module VPC is there, but inside we don't define. Yeah, inside output VPC we have mentioned.
Exactly, man. See, come back in VPC. See how we are writing is module.vpc. Where is it? We have outputs, right?
Yes.
What we have written in outputs?
VPC. We have.
Whatever the name you put here, you put there. No problem.
Okay.
Got it, right? So now we have to put it the same name over here. You want me to repeat again?
Yes, bro. Because this
okay,
module.
you say me how I've written now.
So VPC ID is the individual service.
Okay.
For
yes.
For that service, we have created in that we have one variable.
Okay.
So that is a different service VPC, whereas subnets is a different service. In subnets, we need to attach the VPC.
Correct.
So we have created one output for that VPC and attaching that output in this subnet.
Correct. In the calling function of subnet.
Yes, in the calling function of subnet. Okay.
Got it? It's clear, right?
Yeah. Yes, yes.
So now coming back to the go to the subnets now again. So now we are dealing with subnets. Remember that. Okay. Going back to the subnets. Is there anything else that we have to do it now? This is we'll get it from the Terraform.tfrs. This is also we'll get it from Terraform.tfrs. Nothing else, right? That's it.
Yes, bro.
That's it. Yeah. Any doubt?
That's it, bro.
Okay. Just go back to the calling function. Subnets part is done.
Done.
Now next go to the route table. So in the route table, again, what are the things that we have to give?
In route table VPC, we have to give.
Let's go to the route table we have where we have written. So first, what are the things that we sorry, we can put it over here.
VPC.
Okay. So this you know it, right?
Yes. Module.vpc. We're attaching that output. Okay.
Yeah. Next.
And
Come back to the VPC modules, you'll get to understand. Here for communication purpose, what we have used as a var, this we have used for the communication purpose as a var, correct?
yes, bro.
And this will get it from that thing there, gateway. Previously we have also used this one, right?
Yes.
So one gunshot. Previously we have written as AWS underscore internet underscore gateway, blah, 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 correct?
Yes.
So now where we have to go? We have to go to the gateway underscore ID gateway. Now we have to go to the internet gateway modules, correct?
And create one output for that.
Exactly. Just go to the IB, just cat, just for our purpose.
Outputs.tf.
Outputs.tf. Remember that what we have AWS underscore internet underscore gateway. Okay. Output. I'm naming it as IG. Okay. You can put whatever you want. Your wish.
Value is equal to
AWS underscore internet underscore gateway. Hope you know this. This is a defined resource dot custom resource dot
attribute ID.
Correct. Let's recheck it. AWS underscore internet underscore gateway. Yeah, perfect. Correct.
Yes, bro.
Yeah. Now what we have written? Now just go back here. Where is here? IG.
Module dot.
And what is the name of internet gateway calling function module is equal to?
IG we have given.
Yes. Next.
Output also IG we have given.
That's it. Come down again. Now just go back to our route table. You're understanding, right?
Yes, bro.
Next, go back to the route table. Okay, this part is done. Next, this is also done. Yeah. Next, what we have to give here? Here also NAT is there, right?
Yes.
Now just go back to the NAT. NAT. Yeah, NAT. What we have to do here?
Have to create output for this NAT gateway with the defined resource, custom resource, and attribute.
Correct. What's the name? Let me create this way. It will be easy for me. What we have to do? Output space. What we can give? I'm putting the name as sorry. I'm putting the name as NAT. Okay. And I'm using value is equal to, and what is the name? AWS underscore NAT underscore gateway dot NAT-GW dot ID. Here clear?
Yes, bro. Yes.
See here, AWS underscore NAT underscore gateway dot custom resource and this thing. See ls, and if you go to the outputs.tf, see here, the same thing we created, right?
Yes, bro.
Okay. Now what we have to create here?
Here we need to give module.
Okay. Dot name of the calling function of the NAT one. What we have given? NAT. Dot
output
next
also have given NAT.
So be remember, this is this part. See, this part is the calling function of the NAT.tf's module name, and this part is output name of the modules. Okay, be remember that. Now just go back to the R route table.
Bro, that the second NAT part is calling function of the module.
Correct. This is a name like module route table. How I have given? Similarly, module NAT, the name of the calling function NAT, and this is the output of NAT. Don't confuse that one. Yeah. Now going back to the again, where we are now? Going back to the route table. Okay, this part is done. This part is done. This part is done. This part is also done. This will get it from a Terraform. Now come down. And we were using this one also, right?
Yes.
Previously, we have used this, that part, what we call for the communication purpose. Now just go back to the subnets, correct?
Yes, bro.
Now go back to the subnet, and similarly, we have to write it for private also, correct?
Yes.
Go back to the subnets. I'm using main.tf. Okay, and here I'm using outputs.tf. Output. I'm naming it as public hyphen subnet. I'm just naming it as like this. And what we have to write? Can you repeat it?
Value is equal to defined resource AWS underscore subnet dot custom resource private
what we
public
have
subnet.
written over here. Yeah, public subnet. Next,
and then attribute ID.
Correct. And come down, and this is for the public subnet, and we have even for the private subnet as well, right?
Yes.
Can you repeat it? What we have? We can we can put it as private hyphen subnet. Close it.
And the value is
Value
as per
is
the syntax custom resource, sorry, defined resource, custom, and then attribute.
Correct.
Yes, bro.
Okay. LS output created. Let's go and check it. See here, we have created it, right? It's correct.
Yes, bro.
This is a defined resource, custom resource, attribute. Correct?
Yes, bro.
Now just go back here. This is a name, right? We have put it.
Module dot.
Module dot. And what is the name I've used for subnets for creating like this? I used a word called subnets.
Subnets.
Dot.
Yes.
What we have to use here?
Wait, public subnet.
Exactly. The same
output
name. Yes. Outputs of. See.
Okay.
I have used as public hyphen subnet. The same thing I'm putting here, public hyphen subnet.
Okay.
Okay.
Got it.
And here also it, right?
Module dot subnets dot private underscore hyphen subnet. This is the attribute output.
Save it.
Okay.
Okay. Now, is there anything else? We'll go back to the route table. We are in the route table, right? We are dealing with route table. So now anything else that we have to put it?
Subnet we have created route table ID. It will fetch from there.
Correct.
So yeah, that's it, bro. That's it.
Yeah, that's it here in the route table. Okay. Now come back here. LS. We have LS. We have completed of writing this one. Okay. What we have completed so far? We have done with VPC. We have done with subnets. We have done with route table. Am I correct?
Yes, bro.
Now let's go to the NAT. Okay. And what are the NAT we have? And come back here as well.
Okay.
Okay. I'm into the NAT. LS. Is there anything that we have used for the communication purpose?
Yes, bro. Public subnet.
Yes, public subnet. Here it is a public subnet, correct?
Yes.
Now let's go back to the subnets. We have already created, right?
Yes, bro.
See, we have used public subnet. Same thing, you can use it here.
Okay.
Got it?
Yes, bro.
What's the name we have to use it?
Module dot subnets dot public subnet.
Yes, module dot subnets dot
public hyphen
subnet. Okay, yes. Just for understanding purpose, can you say me where we got this one?
This one is the main configuration in modules.
No, wait. How I got this name? Subnets.
Subnet. This is the calling function of subnets module.
Calling function of the name of this thing module here, correct?
Yes.
And how we fetched here?
This one is output of that public subnet. One of the output we are attached.
You understood, right?
Yes, bro.
Now just go back to the NAT gateway again. Just go back to the NAT gateway. Okay. Is there anything else for communication? Anything else?
No,
nothing.
That's it. Yeah.
Close it. Just here also close it. Next, what is the next steps we have? IG.
IG.
In IG, what is there in the straightforward?
Module
VPC, right? Hello?
Yes, bro. Yes, VPC.
Yeah. Now just go back to the IG. So what we have over here for the communication, we have used this one, right?
Yes.
Just go to the VPC again. So we have already created one output. What's the name we can use it? This one, correct?
Yes.
Module.vpc.vpc. Correct?
Yes, bro.
ls. And what are the things left over? EC2.
EC2.
So what we have to put it here? You say me.
Module dot subnet
Okay.
dot public subnet.
Awesome, man. Awesome. Save it. Is there anything else left over?
CF where's value.
Yeah. Coming to that. Is there anything?
Remaining, yeah, no.
I think, right?
Stored.
Yeah.
Yes.
Yes. Now I'm opening the same file in the another window.
Okay.
ls. First in this, the first one is EC2. In EC2, what are the variables that we have? One variable, two variable, three variable. Correct?
Yes, bro.
Here, what we have to write it? It's already there. 1, 2, 3.
Yes.
Hope you know which variable. This is a calling function variable part. Correct?
Yes. But these variables are same as our module
Correct.
variables.
Next in the calling function, next one is nat.tf. Go to the nat. How many variables that we have to assign? We have to
Only
assign
one.
one variable. This is the name of the variable. Correct?
Yes, bro.
Nat underscore GW underscore name. Nat underscore GW underscore name. Oh, sorry. No save. Next comes to the route table. Correct?
Yes, bro.
How many variables are there in route table?
2.
Public route table, private route table.
Private
Is there anything
route.
else? Nothing is there. Correct?
Nothing, bro. Yes. Bro, whatever the file we are editing now, all these variable entries, this is the calling function variables.tf file, right?
Correct. Exactly.
Okay.
Next, where we are now? Next, what we have to do? Next, now comes to the VPC. Any variable is there? Yes. VPC underscore CIDR block. Correct? Next, IG. How many variables we have? Hello?
Only one variable, bro.
Yes. Internet underscore gateway
Underscore
name. Correct?
Yes, bro. Yes, bro.
If there are any error also, it will throw out in init if you do any spelling mistake also. Okay, next.
Next we have subnets.
1 second. IG is done. Next, subnets. How many we have?
I have 4 variables. Public, private.
1, 2, 3, 4.
Yes, bro.
That's clear. Public underscore name. Oh, sorry. Subnet. Okay, is there anything else here? 1, 2, 3, 4, 1, 2, 3, 4. Correct?
Yes, bro.
Next. That's it. Correct?
That's it. Yes, bro.
Let's save it. Let's open terraform.tfs. Correct?
Yes, bro.
Here we will open the variables. Okay, whatever we created just now. Okay, I'm just writing it from here, my other window. Okay.
Okay. Yeah, my instance type
Oh,
already defined.
yeah,
Just
we have
we can.
yeah, what we have to do next one is nat underscore gw underscore name. Enter. Next, public underscore route table. Correct. Next,
Yes, bro.
private underscore route table. Next, VPC underscore CIDR block. Next,
Public and
internet underscore gateway underscore name. Next, public underscore subnet. Private underscore subnet. Next, public
like
underscore subnet underscore
route.
name.
Okay. Private and
Underscore subnet underscore name. Come back here. How many we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Correct?
yes, bro.
I'll save it first. Let me form it in alignment. Now we can assign it. See, now it formed alignment.
Yes, bro.
Correct? Yeah.
Yes, bro.
Now, see, we have already defined a few things, right? Just go
Yes.
to the previous class. Just for your understanding, I'm just going to the previous class. That is day 8. Day 8. And we have assigned the Terraform.tfs, correct? Just use this. The NAT gateway name, we can put it as a NAT gateway. Okay.
Yes, bro.
And next, public route table, we have used route 0, 0, 0, 0. See here.
Down. Yes.
We have we have used similar this also. Correct?
Yes, bro.
Next, what is the CIDR block that we have used in VPC? Copy. Paste. Next, internet gateway name. I'm using it as internet only. Next, what is a public subnet? You're getting it right?
Yes, yes, bro.
What is a private one? What is the name? Yeah, we can put it a name as public subnet only. Okay, public subnet. And what is the name?
Private subnet.
Finally. Okay, now I'm just going back. Let me hit Terraform FMT. Okay, clear the screen.
Terraform valid.
Now check it.
Yes, bro.
You're clear until here?
Yes, bro. Yes.
Now
So 1 second, bro. 1 second.
Yeah.
So initially for each services like EC2, IG, NAT, we have defined the configuration. And then we have called all these modules in the calling functions. And then for connection as purpose, we have created outputs. And finally, we have defined all the variables.
Exactly. You're clear?
Yes, bro.
I'm hitting the first command. Okay. Oh, so we have to go to the calling function.
Yes.
See, it is downloading each and everything, whatever we used here.
Yes.
See, validate.
Okay.
See, we'll check it. Is there anywhere? See, something is, I done some spelling mistake. I feel. See here. See, I've done a spelling mistake. See here. First, we'll go with the route table where it is saying under route table.tf, under the module route tab, line number 3. I used as underscore and it is asking, did you mean hyphen route table? Okay.
Yes. Yes.
Just go to the route table, line number 3. See, we have to check it out now here. So here we have used underscore route table, correct?
Yes.
Let's go and check the variables. See here what we have written.
Hyphen route table.
Yeah, the mistake is here.
Yes.
Got the point? Here you
Yes,
have
bro.
like this, you have to define it. Debug it, I mean.
Yes.
Here, if it is changed, then Terraform also it will be changed. Yeah, here it is correct. Yeah, where it is. Yeah, here it is. I have written correct only. Probably got
Yes.
correct.
Yes, bro.
Now hit validate. Success, correct?
Yes, bro.
Plan. See, all 11 will be created. Approve. So it's creating and it is under progress. And with this, the module concept is completed, man. Shaker, any doubts so far in the modules? And how you felt the modules is?
Yes, bro. It's very complex. We are defining there and here twice. We are defining variables.
Okay.
And we are maintaining files in number of directories.
Correct.
And we are creating outputs. And again, we are defining all the variables.
Correct.
And we are initializing wherever the provider file lies. But in other Terraform scripts, we executed wherever our main configuration lies, and we have directly defined. So it looks complicated because we need to work on each script number of times.
Exactly. But tomorrow's topic is Terraform registry.
Okay.
If you listen that topic, you'll be able to get to know the importance of modules. Tomorrow only you'll get to know the importance of modules.
Okay.
So what we'll be doing tomorrow is whatever we have written under modules folder.
Yes.
That I'll remove it from this machine.
Okay.
I'll put it somewhere.
Okay, we'll put it in Terraform registry modules.
No, I will do one thing. Tomorrow, what I'm about to do is, whatever the things I mean to say, see, D9.
Okay.
Whatever we put, I created a folder of modules and created.
Yes, yes.
Now, as of now, everything is in one machine.
Yes.
What I will be doing tomorrow is, I'll remove this entire part from this machine.
Okay.
I'll put it somewhere else.
Okay.
Let's say example as I'll put all this in the GitHub.
Okay.
And I'll use only this part from this Linux machine.
Okay.
How I'll be calling from GitHub to this one is the funda.
Okay, bro. Okay.
In the real time, it will be the similar one. Whenever you're writing any new services, this will be keep on adding and you'll be putting in the GitHub repository.
They will push to the GitHub.
And whenever you want to use it, anything, you can use it, depends upon your requirement. Let's say you have written all the modules. See, as of now, you have EC2 module, IG, NAT, subnets, VPC. Let's say you have EBS volume and etc.
Yes.
You can have n number of modules here. You can have it, no problem. In the calling function, whatever you want, you have to create it. Let's say now, example, now here 1, 2, 3, 4, 5, 6. Now you have 6 plus 1 EIP is also there. Now you have 7 services over here, correct?
Yes.
Let's say I want to use only 3 services in the calling function.
Okay.
So you can use it. You can use the 3 services over here. So it is like what my intention is. You'll get to know tomorrow how we will use these modules, putting in the GitHub, how we'll be calling from there to here, and how we will consider this as a registry. You'll get to know tomorrow.
Okay.
And I strongly say that tomorrow, end of our class, you'll get to know that the importance of modules, and you'll only feel how it looks.
Okay. Okay.
Got it? So it's created all.
Yes.
So it's created all. Any questions so far in the modules concept? This the modules part is done.
Okay. As of now, no, bro. We'll see. I'll go for practice and then come back with doubt.
Okay, how you felt while writing and while discussing this module part?
Initially, it is tough, but once we establish, then it will be easy.
See, that's what the understanding is most important over here. Where we have to write the outputs, where we have to integrate that. That is totally important, man.
Yes, yes.
Correct. See, I'm refreshing this one. See, the Raj is created. First, I'll be showcasing the VPCs. Let's open VPC. VPC. You see, this is our new VPC. Default VPC, no. It means this is a new one. Coming to the subnets. Public subnet, private subnet. Okay. If you go to the public subnet, go to the route. Internet gateway is there, correct? And if you go to the private subnet, coming to the route, we have NAT gateway, correct? Hello?
Yes, bro. Yes.
Yeah. Coming to the route table, these are new tier route tables, and the subnets are connected. Okay, and subnet association, you can see private route table is set to this. And if you come here, public subnet is set to this. Coming to the internet gateway, see these are new internet gateway, it's created. And next, it's created and attached to the VPC.
Yes,
and it's coming to the EIP. See, EIP is created.
And check the for VPC is true, no, bro.
Nothing like that. See, you can see, is anywhere here saying yes, it's connected to the VPC or something? You just say
no.
That's what. And next, come down, come to the NAT gateway. NAT gateway is created. See here. Correct? It's connected to the VPC. See here. 317. See, all done. Got it?
Yes, bro.
That's it, man. So today done with the session. And if you have any doubts, like you can shoot me out through call or you can ping me on message. Okay?
Okay, bro.
Chalo, Raja. See you tomorrow.
Bye, bro.
Bye.